Hi, welcome to BC Video 10.3a Part 2, more on the calculus of parametric equations.
15 through 18, find an equation of the tangent line at each given point on the curve. So here's an example of what they'll give you. They'll give you a diagram. Now, a lot of you are able to look at this line and go, oh, that's a horizontal line, that's a vertical line, but not so easy to know what the equation of that line is. So that's going to be a more interesting line for us to find, but whatever. So here's number 16. So they're telling you this is the graph that you get. It's actually drawn counterclockwise. When you have x minus 3 cosine theta and y equals 3 plus 2 cos theta, plus 2 sine theta. So they want you to find the equation of each of these blue lines at each of these points. So what is the equation of this blue line, which is tangent to our curve at this weird point? What is the equation of this blue line, which is tangent to the curve at this point? And of course, the same thing, what's the equation of that line? Now, it looks pretty well like this is a vertical line, x equals -1. Sure looks like this is a horizontal line, y equals 5. But we don't know what's going on over here. Okay, so I'm going to take the point -1, 3. Remember, if I'm looking for the equation of a line, I need a point and a slope. I have the point -1, 3. The slope of the tangent line is dy dx, which is dy d theta over dx d theta at that point, -1, 3. So dy d theta going back up is 0 plus 2 cos theta, which is 2 cos theta. The derivative of 2 minus 3 cos theta is 0 minus -3 cos theta, which will be positive 3 cos theta. So we end up with 2/3 cos over sine, better known as cotan, which would give, at the point -1, I would hope that you know that the graph of cotan at x equals -1. Why am I crazy here? Oh, because at -1 theta is 0. That's down here. There we go. Okay, so you end up with 2 cos theta over 3 sine theta at the point -1, 3. But -1 is an x value and 3 is a y value, and all I've got here is theta. So the first thing I did is I replaced cosine theta over sine theta by cotan theta. But I need to figure out what theta is at the point where x equals 1 and y equals -3. So you go back to your equations and actually replace the x by -1, replace the y by 3, and then, oh my goodness, solve the system. So this one over here ends up being -3 equals -3 cos theta, which means cos theta is 1. These 3's cancel, and you're left with 0 equals 2 sine theta, which means sine theta equals 1, which means it's the angle theta equals 0 radians. And that's where I got this 0 right here. And then I have the cotan of 0. Well, the cotan of 0 doesn't exist. So therefore, the slope of the tangent line doesn't exist, which means it's a vertical tangent line. And its equation, of course, is x equals -1. Okay, so now we're going to move on to, sorry, I keep yawning. Graph the parametric curve using the TI, and then we're going to use the TI to find dx, dt, dy, dt, and dy, dx at the given value of the parameter. Then we're going to find the equation of the tangent line to the curve at the given value of the parameter. And finally, we're going to use the TI to graph the curve and the tangent line. So this is like number 20. So this is a set of parametric equation. This is the t value at which we're doing that. So one of the things to realize here, of course, that for y, the t cannot be 0. When t equals 0, you would realize that x would give you -1, which would mean you have a vertical asymptote there. And when t equals 0, this actually would not exist. Okay? So we're going to look at the graph of that on the calculator. X equals t minus 1, y equals 1 over t plus 1. Now, this is the graph I get if I let my t go from -10 to 10. If you leave it at 0 to 6.28, you're not going to see very much. I think, oh, I didn't show it here. Okay, now one of the things you will notice sometimes is it'll look like it's drawing in the vertical asymptote. It's not, it's just connecting 2 points. It's not really a vertical asymptote, but you should know what the actual graph looks like. You should be able to figure out the direction of said graph. Okay, more questions like number 20. Oh, so this is it on the calculator. So if you look at it on the calculator, if you want to find dx dt, which is d dt of x1 of t. Now remember, we stored this in the calculator, so we already have x1 of t equals t minus 1. We already have y1 of t equals 1 over t plus 1. So if I have dx dt and dy dt, then I can find dy dx, because dy dx is dy dt over dx dt. So that's what I've got right here. I've got d dt of y over d dt of x, and I get the answer of negative 1 over t squared. Okay, so the question, let me go back and look at that question. This is like number 20. Okay. Find an equation of the tangent line and graph it and the tangent line. Okay, so what we have is we need our slope of our tangent line, which is our dy dx. You can't just call it the derivative anymore. So we figured out over here, using the calculator, that our dy dx is negative 1 over t squared. So that's what our slope is, which is going to equal 0 never. Remember, I'm looking for critical numbers. And it'll be undefined, which is negative infinity at t equals 0. So if you go back in your original equations and replace the t's by 0, we know that when t equals 0, x equals 0 minus 1, which is negative 1. So we get a vertical asymptote. And when t equals 0, we get y equals 1 over 0 plus 1, which is positive infinity or negative, depending on which side 0 approaches 1. So what you have is that dx dt at t equals 1 is 1. dy dt at t equals 1 is 0.00445. And dy dx at t equals 1 is negative 1. Okay, find the equation of the tangent line now at the point where t equals 1. So we need a slope and we need a point. We've got the point 0, 2. We've got the slope negative 1, and we just put it into the point slope 4. Okay. And remember, that's because we knew dy dx was negative 1 over t squared, and now we know that t is negative